In this lesson, we're going to continue our discussion of computer systems and computer hardware. In particular, I'm going to use a fairly simple, but possibly too simple, of a description of how a computer works. But I think it'll give you a general idea of what's going on with your computer. And I'll often use an example of a kitchen to describe what a computer does. If you were in the kitchen and you were about to prepare a meal, you would go to some secondary storage location, such as a pantry or a fridge or something like that, to get your raw material. Now, as a general rule, you would not sit in the refrigerator door and prepare the meal. Quite the contrary, you would move the raw material from that secondary storage location. So we're going to say move raw material from that secondary storage location to some primary storage location. And that primary storage location in the kitchen is the counter or the table or the stove top or someplace like that. And it would be there that you would actually process the food. Now let's assume that for the sake of our discussion that we're talking about cooking dinner and it's 3 o'clock in the afternoon. If you finished preparing the meal, you probably wouldn't let it sit out there on the table for the next 2 or 3 hours. You would actually move that processed food back to that secondary storage location until you were ready to use it again. And that's just a general, simple explanation of how a kitchen might work. Computers work very much the same way. If you were about to process some data, for example, you'd go to some secondary storage location again, except in this case it's called a disk drive, or you might be using cloud storage to store your data. And you would copy that data from that secondary storage location. So we're going to say copy raw data from that secondary storage location to a primary storage location. And in the case of a computer, that primary storage is a piece of equipment called random access memory. We usually abbreviate it and call it RAM. And so primary storage in a computer is RAM, and that's where you actually do the processing, not on the disk, but you do it in RAM. And there are reasons for that that we'll discuss shortly. Now, after you have finished processing your data, then you would then copy that processed data. So we're going to say copy back to the secondary storage location, back to the disk drive. And that's pretty much how that works. And granted, just like the kitchen analogy, it's a fairly simplistic approach to it, but I think it does give you that idea of how it works. The only real difference between this kitchen and this computer is that in the kitchen you move that raw material, whereas in the computer you copy it. You see, by that I mean that when you go out to your disk drive over here and you get the raw material, you actually copy it into RAM. You copy it into RAM. You don't really remove it from the disk. And then after you have been processing that data with whatever application you're using, Word or Excel or whatever, then you would copy that processed data back to the disk. But it would still remain in RAM until such time as you actually close the program down. Now that is the reason why when there is a power failure and you lose power, you don't necessarily lose all of your work. You would lose whatever you did since the last time you saved, but it might not be very long. And in fact, many of the applications we use today automatically save periodically without us even having to tell it to. So that's just a general idea of how a computer works. It goes to secondary storage, and these are terms that you should understand and know, and it gets the data and moves it to primary storage. And primary storage in a computer is RAM, and secondary storage is any type of device that you store the data on. Now let's talk about secondary storage and primary storage a little bit more and some of the characteristics of these two forms of storage. Secondary storage is considered semi-permanent. That means that when you put something on a disk or in the cloud, it stays there until such time as you delete it. Secondary storage, as a general rule, is much slower than primary storage is because secondary storage is usually mechanical, like a disk drive. It's got heads and disks that spin and so forth. Now, unless you're talking about the cloud storage, and then you run into the issue of communication speed and things like that. So it is usually a slower type of storage. However, secondary storage normally has a large capacity, much larger than primary storage does. And we'll talk about some of these capacities here shortly. And when you measure the cost of storage in terms of this, that capacity versus cost, secondary storage is much less expensive. Primary storage over here on the other hand, and what is primary storage in a computer? Random access memory. Primary storage, on the other hand, is referred to as volatile. And what does that mean? That means it requires power. So when the power goes off, whether you turn off the switch or it just goes off because of a power shortage, whatever's in RAM goes away, which can be a problem. RAM, though, is not mechanical, it's electronic. And because of that, it's much higher speed than a disk drive is. That's really the main reason that we use RAM for our processes rather than trying to update data on a disk drive on an ongoing manner, and that is because of the speed. And when I say that you actually work in RAM, generally speaking, that's true. But with systems today that we refer to as virtual memory, your operating system actually bounces back and forth between RAM and secondary storage, bringing in instructions as they're needed, which is why you can run extremely large programs when you don't have that much RAM, because it doesn't have to bring the whole program in at one time. Once upon a time, it did have to do that. RAM, on the other hand, has a very limited capacity when compared to secondary storage, and because of the cost and capacity, it is generally much more expensive than is secondary storage. So this is your workspace, and this is your storage space over here. This is your computer pantry or your computer refrigerator. Now, speaking of RAM and capacity, what do we know? We know that computers actually store data in ones and zeros. So I wrote zeros and ones. Binary digits, and these are referred to as bits, if you recall. So data is stored in a computer in bits. And in the coding system that is most often used today, it takes 8 bits to actually represent a character of any type, at least 8 bits. And what do you call 8 bits? It equals a byte. Okay? 8 bits makes a byte. Here is 8 bits right here. And that 8 bits actually equals a capital A using the coding system that we often use today in computers. Now, if the smallest character that you can represent takes a byte, the next step up is 1,000 bytes, and that is referred to as a kilobyte. And then if you have 1,000,000 bytes, that's a megabyte. A billion bytes is a gigabyte. What's a billion bytes? A terabyte. And these are the capacities that you have in computers, storage. And when we talk about secondary storage as opposed to primary storage, these days you can easily find secondary storage devices that measure in the terabytes. Whereas I've not run across a personal computer yet that has a single terabyte of RAM. A common high performance personal computer might have 8 gigabytes of RAM, which is significantly less, as you can see. And the reason for that is cost, quite frankly. I mean, if it weren't for cost, I think we would all load up our computer with as much RAM as we possibly could, because that'll make the whole thing run faster and all that. But unfortunately, the cost is prohibitive. And so in terms of primary storage, you are normally talking in terms of gigabytes, whereas in secondary storage, we are often talking in terms of terabytes. My first personal computer I had 16 kilobytes of memory. Goodness gracious, that's hardly anything. And today my computer has 4 or 8, I don't really recall right offhand. So there you have a brief description of how a computer actually works. Granted, it is a simplified description comparing it to the kitchen, but I think it gets the message across. And we've talked a little bit about some of these different measurements of the binary data. So that will conclude this lesson.